Welcome. This is page 4 of the percents notes, and our first example here is going to be about a county's population that is changing by a negative percent. So in the previous video, we were like, oh, that must mean the population went down. So let's just do that within an example. So we have Wheeler County, we have a percent change, it's negative 6.85%. That's happening over the course of these 10 years, and we have an initial population in 2000. So the strategy is going to be determine what 6.85% represents when 1547 is the whole, and then subtract that. Okay, well, 1547 times 0.0685, which is the percent represented as a decimal, equals 1547 times 0.0685 equals 106 people. So, in 2010, the population was 1547 minus 106, which is going to be 1441. Great. Let's also note that we could also have calculated 1441 by 1547 times 0.9315. And you're like, where did you get that number from? This is 1547 times 1 minus 0.0685. So just like when you are calculating percent change that is positive, something grew by a certain percent, you can multiply by 1 point, whatever that percent is, written as a decimal. You can also do that same thing for when something is decreasing. So anytime there's a change in a value by a percent, it's always going to be that whole times 1 plus percent change. And since our percent change was negative this time, this percent change, that plus sign turned into a minus sign. But that would have also worked if we were growing by 6.85%, then the change would have been positive. All right. Oh, and I guess we ought to check that to make sure, right? Just for clarity or peace of mind. 1547 times 0.9315. And right, the little decimals there just because we rounded, but it rounds appropriately. All right, let's look at the second one. Here we got another county, Coos County. Its population increased by a percent from 2000 to 2010, and what they tell you is the population in 2010. So it's important. All the problems that we've had, we've been kind of given an original and calculate a final based on the growth. This problem still tells you the change. Still tells you the percent change. But asks for the original amount. Instead of the final. And I mean, importantly, they do tell you the final amount. They'd have to tell you one of those two. The other thing to think about in this problem is it's maybe our first one where the percent itself is a tiny number. It's a number that's less than 1. And that doesn't really change any of the ways that we approach these problems, but it's something to make note of. It's another place where a mistake can happen. You might look at that number and think, oh, it's already been converted into a decimal. But it's like, no, percent changes can be any number, including tiny numbers, between -1 and 1. All right, so to think about this problem, though, maybe ask yourself, what number, when it grows by 0.42%, turns into 63,043? That kind of question translates into an equation where you say, if x is that number that we want to know about, it's like x times 1, and we'll write as we did in the previous problem, 0.42 equals 63,043. So this side, oops, it's not a good color. This piece right here will account for the growth. This is our final amount. And this is the mystery number. Like, what population do you need to have in order to end up at 63,043 after you grow by 0.42%? And after you write this equation down, it's just a matter of solving for the unknown. So let's go ahead and do that. So, rearranging. We have x equals 63,043 divided by 1.0042. And so I've just completed the addition there. I divided both sides of this equation by 1.0042. And we can just make our calculator do that. $63,043 divided by 1.0042. And looks like 62,779. Oh wait. 62,779. And just as like a sanity check on your response, it's just good to check your work in some fashion. This 62,779 is smaller than 63,043, but it's not that much smaller. So if this number grows a little bit, it's reasonable to conclude that if it grows by like a tiny percent, then it could get to 63,043. Okay, that's it for today.